Hello everyone, welcome back again. I am Professor Salim Mullah from PG Mosaic College of Engineering, Wagholi, Pune. In this video lecture, we will learn about the concept of consecutive coordinates and independent coordinates. Now, this concept is utilized in theodolite traversing and it is used to determine the area of particular closed traverse. So, this lecture is very useful and very important while you determine the area of particular traverse. So, first of all, let us learn about what is latitude and departure. Okay, so for that purpose you have to observe this figure. Here A and B, these are the ground points which are connected by an imaginary line that is called as the survey line, having length small l in meter. Now here the theta is the bearing of line AB, okay, which is measured from the north direction. Okay, so here with reference to this survey line, what is the meaning of latitude? Latitude, the definition is the coordinate length of survey line, which is parallel to the reference meridian or north south side. Okay, now this is a meridian or north south side which is parallel to this particular reference, then that length of that coordinate length is known as latitude, Now what is the meaning of departure? It is simple. The coordinate length of survey line AB perpendicular to the reference meridian or parallel to the east west side. Remember this thing, it is the coordinate length of survey line perpendicular to the reference meridian or parallel to east west side. That term is known as departure. Okay, so by using this bearing, okay, so here the value of departure or length of departure being same like this. Similarly the latitude becomes same length by this. Okay, are you getting this? Then how to determine the value of latitude or how to determine the formula? So let us see. Now this is a theta, now this is a departure and this is a latitude. So if I say sine theta, now sine theta is equal to opposite side upon hypotenuse, and it is, now what is this? Opposite side is the departure. Okay, so if you want the value of departure, you can directly convert that formula, that is departure is equal to L sine theta. Okay, and what about the latitude? If I say cos theta is equal to adjacent side upon hypotenuse. Okay, so latitude becomes L cos theta. Okay, so here latitude, if I say cos theta, okay, then it becomes cos theta it becomes latitude, that is this dimension, divided by hypotenuse, and hypotenuse is, that is the length of AB, then you can say divided by L, then latitude becomes L cos theta. Now what about departure? Just use this formula, sine theta, opposite side is this dimension and this is directly parallel to this, that's why it is departure upon hypotenuse, that is the L. Okay, so here that can be converted into departure is equal to L sine theta. In short, latitude is indicated by capital L, small l is the length of that line, and theta is the bearing. Now remember, bearing is always in reduced bearing, okay, not in whole circle bearing. Now if the whole circle bearing is given in the problem, then you have to convert it into reduced bearing. Okay, got it? Now next important thing is, here you can see the line OA, OB, OC, OD, these are the lines lying in each quadrant. Okay, so OA lies in northeast, OB lies in southeast, OC lies in southwest, and OD lies in northwest. So what is the latitude and departure of that lines? Here we can see in first quadrant, now this is first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. Okay, so what is this? What is the latitude? Latitude is a vertical line, okay, parallel to the north south direction, and departure of that line is horizontal line. So here this line becomes latitude of OA and this length becomes departure of OA. Similarly in second quadrant, this is what? Latitude of OB, and this is horizontal line is the departure of OB. Okay, you can same refer for OC and OD, as this is a departure of OC, this is a latitude of OC. This is again for OD, latitude and departure. Now one more important concept, what is northing, what is southing, what is easting, and what is westing. Okay, now if the latitude is measured upward or above the east west side, then that latitude is known as northing. Okay, and the sign convention for northing is positive. Remember this thing. Got it? If the latitude is measured downward or below the east west side, then it becomes southing. Okay, and it is negative. If the departure is measured towards east side or right hand side of the north south side, then it is known as easting, and that easting is positive. If the departure is measured towards west side or towards the left side of the north south line, then it is called as westing and it is negative. So this is the sign convention for latitude and departure. Latitude is positive above east west, negative below east west. Departure positive towards east side, departure negative towards west side. Okay, so what is the sign convention for first quadrant, second quadrant, third quadrant, and fourth quadrant? So here in first quadrant, this is a latitude, so this is positive. Okay, so refer the first point, first dimension is a positive, that is for latitude, and departure for secondly you have to mention departure positive. Okay, in first quadrant latitude is positive, departure is positive. Okay, in second quadrant here latitude is negative, and departure is again positive because it is east side. Thirdly, in third quadrant departure latitude is again negative, okay, and departure is westing, that's why it is again negative. Okay, now for fourth quadrant latitude is positive, okay, and departure is westing, that's why it is negative. Okay, so for first quadrant positive, remember first sign is for latitude, second sign is for departure. Okay, so here positive, negative, negative, and positive, negative. Okay, so here you have to refer first latitude, departure, latitude, departure, latitude, departure, latitude, departure. Okay, and depending upon this terminology you can find the area of particular traverse. So if the closed traverse is given in the problem, so first of all how will you find the latitude? So here I will show you the important thing. Now this is A, B, C, D, E, A is a closed traverse. Okay, if the length of AB, length of BC, length of CD, length of DE, and length of EA is given in the problem, then you have to determine, you need to determine the latitude and departure of that line by using the theta, that is the reduced bearing, and the length of that particular line. Okay, if the whole circle bearing is given in the problem, then you need to convert it into reduced bearing. Okay, so by using this, here you can see the AB line I need to first complete this work. So AB, what is the latitude of AB? Now this is the latitude of AB. This vertical line indicates the latitude of AB, and this is the departure of AB. Got it, everyone? So for next line BC, now here this is the vertical line. Okay, here you can see only this dimension is indicating latitude of BC, and this dimension, horizontal dimension, indicated departure of BC. Okay, now similarly if I consider the CD, then the latitude, the departure of CD is only part of this line. Okay, and the departure latitude becomes the vertical line, and it is total this dimension. Okay, so for DE, latitude is vertical, okay, only this term, and this is departure. Got it? And for EA, latitude is up to this line and departure is only part of this line. Okay, are you getting this term? How to determine the latitude and departure of this particular traverse? By using the reduced bearing or quadrantal bearing and the length of that particular line. Okay, let us learn about the independent coordinates. What is the meaning of independent coordinates? Now what we learned, that was consecutive coordinates. So latitude and departure are the consecutive coordinates. Now what is the meaning of independent coordinates? Sometimes it is also called as the total latitudes and departures. Okay, so what is the meaning of independent coordinates? So here this is a closed traverse, okay, for the reference. Now here we know with the help of this closed traverse we can directly determine their latitudes and departure, and with the help of these latitudes and departures, okay, we again convert it into the independent coordinates. So how to determine this independent coordinates? So here you can see independent coordinates, the coordinates of any point, okay, A, B, C, D, any point with reference to common origin. Now this is the origin, okay, X and Y axis, these are the common origin, okay, common origin are known as independent coordinates of that point, are known as independent coordinates of that point. So here point A, if I consider the point A, now this is a Y line and this is the X axis, then I will make the origin here. Then if traverse is here, then from the particular origin I will measure the horizontal direction. I will measure the x1 in a horizontal direction and y1 is the vertical direction. Okay, now this is on horizontal plane, so for better understanding I am using vertical and horizontal words. Okay, so don't get confused here. So x1 for point A, x1 is the coordinate from y direction and y1 is the coordinate from x direction. So x1 y1 is the coordinate of point A. Okay, similarly x2 and y2, okay, coordinate of B, x3 and y3, these are the coordinates of C, x4 and y4, these are the coordinates of D, then x5 and y5, these are the coordinates of E. Okay, so by using this coordinates we can directly determine the area of particular land or particular traverse. Okay, so what is the independent coordinates? When we measure the coordinates of particular point from a certain origin, then that coordinates are known as independent coordinates. Okay, as well as it is also known as the total latitudes and departures. So by using, if now here we consider only the coordinates of A as a reference, and with the help of the latitudes and departure of all the lines we can determine the total latitudes, we can determine the coordinates of B, coordinates of C, D, E, etc. Okay, so here how will you determine? I am again referencing this figure, two figures. Here you can see, okay, here you can see, for your understanding I am going to, okay, now here from this figure we can directly determine the latitudes and departure. Okay, and if we consider the y axis and x axis, okay, then here I will draw the y and x axis. Okay, so here I can consider the coordinate of A from y. If I consider x1 and if I consider y1, okay, now with the help of this x1 y1, okay, and all the latitudes x1 y1, I will find the value of coordinates of B. Okay, that I will directly add this x1 to this length. Now here this is the departure. Now here x direction indicate the departure and y direction indicate the latitude. Okay, so here x1 add the departure of AB. If I add the departure of AB, I will get the coordinate x coordinate of P. Similarly, in y1, if I add the latitude of AB, then I will get the latitude or y coordinate of B. Okay, so here I can directly write x2 y2. Okay, so for x2 you have to do x1 plus departure of AB, and for y2 you have to do y1 plus latitude of AB. Okay, similarly for C point, if you want the coordinate of C, then you have to x3 is equal to, now here x2 is known to you. So, okay, from up to this direction you know the value of x2. Okay, you know the value of x2, then adding this terminology only, you have to add the departure of BC. For x3 you have to add x2 plus departure of BC. Okay, we can directly determine the value of departure of BC. Then what about the y2 y3? If I want the value of C y3, then what about y3? Just you have to minimize this value. So you have to observe by using this figure whether we need to use positive value or we need to use negative value. Now I want the value of y3 here. So here the y3 value is up to C and y2 is up to B. So you have to minus this value, okay, latitude of BC from y2. So y2 minus, okay, you have to do y2 minus latitude of BC. Got it? So here you can get the value of x3 and y3. Okay, got it? Okay, again if I want the value of x4, now here if I want the value of x4, okay, then I will do the calculation of x4. Now here y4, sorry, now this is x4. Okay, for better understanding I am using this figure. Okay, what is x4? X4 is what? x3, we know the x3 value, just I will minimize this value, x3 minus, now this is what? Departure of CD. Okay, here you can see departure of CD. Then I will minimize x4 is equal to x3 minus departure of CD. Okay, now for y4 again, now this is y4, again I will use y3 minus latitude of CD. Okay, so in this way you can calculate the value of coordinates. Now about x5. Okay, now x5 is here, okay, from each direction. Then here I will use x4 minus departure of DE. Okay, and y5 is equal to, now here is the y5, now here up to y4 I know, then I will directly use this term y4 minus latitude of DE. Okay, so in this way you can calculate the value of coordinates. You have to just take the reference of x1 and y1, and then you need to calculate the value of x2 y2, x3 y3, x4 y4 and x5 y5. Okay, so this is known as the independent coordinates. Okay. Now next important thing is how to determine the area of traverse or closed traverse by using the independent coordinates. Okay. So here refer this figure, x1 y1, as I say, x1 y1 coordinates of A, x2 y2 coordinates of B. Now here the traverse is going like this. Okay. You may select you may say clockwise traverse also. So here A, B, C, D, E, A, this is the closed traverse. x1 y1 coordinates of A, x2 y2 coordinates of B, x3 y3 coordinates of C, x4 y4 coordinates of D, and x5 y5 coordinates of E. Okay. So by using these coordinates you have to determine the area of this closed traverse. So how? You have to use these coordinates and arrange the coordinates in determinant. So you have to write here, I have shown the departure values, that is x1 to x5 in black color, and latitudes value which refers in y direction, y1 y2 y3 y4 y5 in red colors. So here how to determine this area of traverse by using these independent coordinates. So here you can make the dotted line x1, you can join the dotted line x1 to y2, x2 y3, x3 y4, x4 y5, x5 y1 again. So here it is important thing, x1 x2 x3 x4 x5 again you have to, because this is the closed traverse, it starts at A and closed at A, so that you have to arrange these coordinates like this, x1 x2 x3 x4 x5 x1 y1 y2 y3 y4 y5 y1. Okay. Again you have to make the dot line x1 to y2, x2 y2 y3 x3 y4 x4 y5 x5 y1, and in this direction you have seen, you can see in the red direction, red lines, y1 to x2, y2 x3 y3 x4 y4 x5 y5 x1. Okay. So arrange these coordinates in determinant like this. Okay. Now here first of all you need to determine, you have to, for particular, if you want the area of traverse, then you have to do two important multiplication and additions. So here summation of A is the sum of product of the coordinates which connected by dotted lines. Okay. So x1 y2 plus x2 y3 plus x3 y4, it is the multiplication, plus x4 y5 plus x5 y1 again. Okay. Similarly for summation of B, that is the product of second coordinates from the y, okay, and their summation, y1 x2 plus y2 x3 plus y3 x4 plus y4 x5 plus y5 y1 x1. Okay. So find out this, the value of summation of A by using this term, okay, and summation of B by using this term. And if you want the area of the traverse, just use this formula, area of traverse A B C D E A is equal to summation of A minus summation of B divided by 2. Just use this formula, you will get the area of the traverse. Sometimes the area will be form negative, area will be in negative. So if answer is negative, then you have to ignore it and consider it as a positive, and area of the traverse you need to mention in square meter or square foot, whatever the unit is given in the problem. So this is all about the consecutive coordinates, that is latitude and departure, and independent coordinates, that is total latitudes and total departures. Again we seen how to calculate the area of the closed traverse by using the independent coordinates. So remember this thing. Okay. In the next lecture we will see how to calculate the area of closed traverse by using the actual values. Okay. Hope you enjoy this session. If you like this video, please hit the like button, and if you are new on this channel, then subscribe the channel for new updates.